Earth Systems 3209, Unit 2, Historical Geology. References in the text can be seen in Chapter 6, Chapter 8, Appendix A, and Appendix B. Unit 2, Topic 2.1, Distinguishing between Relative and Absolute Time. This presentation will focus on demonstrating an understanding of the processes and features used to establish relative and absolute time. Here we'll have a look at relative and absolute time, and we'll give an overview. Detailed discussions on relative and absolute time will be done in later presentations. Many geologic events that Earth scientists study occurred millions of years ago. The ages of these events can be determined in two different ways. First of all, we can look at the ages of events in relative time, where we compare one event to another. And secondly, we can look at events in time in absolute time. Here we pinpoint exact ages of the time an event had occurred. Both of these dating methods are needed to accurately record geologic time chronologically and to organize the geologic rock record. First, let's look at relative time. Relative time places events in a sequence of formation, but does not identify their actual date of occurrence. Relative time does not involve numbers, but rather in a sequencing of events by comparing events. This method of dating can't tell us how long ago something happened, only that it followed one event and preceded another. An example could be your students' ages in your classes. If you look at a class full of students with a variety of levels from level 1 to level 3, we could place all the students according to relative time. Students in level 1 would be younger than students in level 2, which would be younger than students in level 3. Therefore, you chronologically place students in an order from youngest to oldest based on their level, assuming that they're in the age category as appropriate to each level. If you want to look for information in the textbook, text references can be seen on pages 7-8 in the textbook and also on pages 218 to 228 in your textbook. Some examples of relative time include the relative dating principles. First principle would be the principle of or law of superposition. Second, the principle of original horizontality. Third, the principle of cross-cutting relationships. Fourth, the principle of inclusions. Fifth, fossil succession. Sixth, unconformities. Seventh, you can look at folding and faulting. And eighth, contact metamorphism. All 8 of these scenarios are used when we look at relative dating. And if we're looking at rock outcrops in the field and we want to chronologically place rock units in order of occurrence, all 8 of these principles and dating techniques can be used. Note, these dating principles will be discussed in detail in another presentation. When we look at absolute time identifies the actual date of an event and pinpoints the age of occurrence. Therefore, pinpoints means it gives us the exact time which an object occurred. It involves numbers to count or calculate from a known event. An example could be the extinction of the dinosaur, which occurred approximately 66 million years ago, and also the age of the Earth is approximately 4.6 billion years old. Both of these ages have been determined using radioactive dating methods. For information on absolute time, you can refer to the text reference from pages 228 to 235. When we look at absolute dating, some methods include: number 1, tree rings. The age of tree rings is found by counting the total number of rings. If we look at the diagram to the right, we will notice that within the diagram you have dark rings surrounded by light rings. One yearly cycle will be represented by a dark ring in addition to a light ring. So if we count from the center out, we could see that this tree is 1, 2, 3, 4, 5, 6, 7 years old. So you can get an absolute date of a tree by looking and counting at the rings in cross-section of the tree. The second method that we can use to find absolute time is varves. Varves are sedimentary layers that show yearly cycles. Varves are often seen in glacial lakes dating back to the Ice Age. So when we look at a varve, and we look at the sediment in the bottom of a glacial lake, we will notice that we have summer sediment, which is brought down by the rivers, the glacial rivers flowing down from the meltwater of glaciers and flowing into the lake. And then in the wintertime, the lake will freeze over and very little runoff water will be running into the lake. During this time, the organic material in the lake will die, and that dark materials, the organic material, will settle on top of the light layers. So if we look at the diagram to the right, we can actually see light sediment followed by dark sediment. The light sediment would represent summer sediment, whereas the dark sediment would represent the winter sediment from organic matter that died in the lake and settled to the bottom. So if you wanted to find the age of a glacial lake, we would be able to count the light and dark layers, and two of these layers, a light plus a dark, would represent 1 year of age. The third way of finding absolute dates is by radiometric dating. Radiometric dating is used to calculate absolute ages of rocks and minerals that contain radioactive isotopes. This topic will be discussed in a later presentation. Let's look at some examples taken from past public exams. While taking a mud sample from the bottom of the glacial lake, a geologist discovers volcanic ash covered by 200 layers of sediment. These layers alternate between light and dark color. How many years ago did the volcanic eruption occur? When you read through the problem, the scientist discovers that volcanic ash found in a glacial lake is covered by 200 layers of sediment, which alternate between light and dark color. If we look at the diagram to the right, we will see that one varve would include both a light and a dark layer. A light layer followed by a dark layer. That would indicate 1 yearly cycle of sediment that was deposited in the glacial lake. So if we have 200 layers of alternating light and dark sediment, each yearly cycle would represent 2 layers, a light layer followed by a dark layer. Therefore, if there was 200 layers, the volcanic eruption must have occurred 100 million years ago. Example number 2. Which geologic principle states that in a non-disturbed sedimentary sequence, the bottom layer is oldest? Through the law of superposition, we notice that the layers on the bottom of a sedimentary sequence is older than all of the layers above it, and it would also be younger than any layers located below it. So the answer to example 2 would be superposition. The answer would be C. Next question. Which type of dating will be used to tell the age of a tree using tree rings? As previously stated, tree rings are used to find absolute ages of samples. Example 3. This example takes in consideration a long answer question. The question reads, explain how the principles of superposition and cross-cutting relationships are applied when using relative dating. So to answer this question, we must focus on using the principle of superposition, also referencing the principle of cross-cutting, and showing how these are used to determine relative dates. Relative dating determines the chronological order of events by comparing events. Both principles, superposition and cross-cutting relationships, are examples of relative dating. Superposition compares undisturbed horizontal layers, stating that the rock layer is older than the layers above, and a rock layer will be younger than all the layers below. Also, if we look at cross-cutting relationships, the law of cross-cutting states that a rock unit or geologic event, such as a fault, that cuts across other rock units is younger than the units they cut across. In order for a unit to cut across other units, therefore, the layers had to be there first in order for a rock unit to pass through them. So in conclusion, the principles of superposition and cross-cutting are used to determine relative dating based upon the definitions of each. Your turn. Take time and complete the following questions. A solution will follow on the next slide. The question reads, refer to the diagram to describe the relationship between superposition and relative time. You can stop the recording now to prepare your answer. Let's have a look at the solution to the question. To reiterate, the question states, refer to the diagram to the right to describe the relationship between superposition and relative time. To answer this question, we must first identify what is meant by relative time. Relative time is found by comparing one event with another and chronologically arranging them in order of their age. The relative ages of the layers of the diagram can be seen when referring to the law of superposition, which states that the lowest layers are the oldest and the upper layers are the youngest, assuming that the rock sequences have not been disturbed. So when we look at the 4 layers of rock, in this case, the layers at the bottom, in this case the shale, which contains the trilobite fossil, and the shale, which is 2 layers up, which contains a shark-tooth fossil. The shark-tooth fossil will be younger than the trilobite fossil, and this is determined because of the law of superposition, which states that if all 4 rock layers are deposited and they're undisturbed, then the layers on the bottom will be older than all the 3 layers that are located above. Therefore, the law of superposition states that relatively the bottom layers are older than the top layers. In summary, let's look at the overview of the points covered. When we look at relative time does not identify their actual date of occurrence. Also, relative time does not involve numbers, but rather a sequencing of events by comparing the events. And thirdly, relative time can't tell us how long ago something happened, only that it followed one event or it preceded another. Therefore, relative time is not an exact time. It's a time where you organize events in relative order from oldest to youngest by comparing the events. And in this case, comparing will be the key factor that you'd use. When we look at absolute time identifies the actual date of an event. Absolute time pinpoints the exact time in history when something took place. And thirdly, absolute time involves numbers to count or calculate from a known event. So when we find the age of an object or a rock layer according to absolute time, we know exactly when that time of occurrence had taken place, whether it be a rock unit that formed or an organism that died and the fossil was preserved in sedimentary rock.